Right, so now we're going to talk about some graphing stuff and optimization. And so before we get into this example, just a reminder, when you're looking for maxes and mins, which is of course a huge idea in calculus, you're often focused on the derivative, right? And you'd be focused on critical points, which would be places where the derivative equals zero. And so sometimes you're looking at a graph of the derivative, sometimes you're looking at an equation that you can factor or something. So in this case, we've got two critical points, places where the derivative is zero, and then we set up the number line, and we look to see places where that second derivative or the first derivative changes sign, and then we're writing good explanations, right? We talk about, oh, where does the derivative changes from negative to positive? That means the function changes from decreasing to increasing, which means A would be a relative minimum, right? It's going decreasing and then switches back to increasing. B would be the reverse, changes, F changes from increasing to decreasing. And when we write our explanations, we're just being really careful about the words positive and negative versus increasing and decreasing. Are we talking about F? Or are we talking about F prime? And so that's sort of a big idea. The other thing to keep in mind is sometimes you don't have enough information to make this full number line, but you do know you have a critical point. So maybe A is a critical point, but you can't make that full number line. In that case, what you can often use the concavity to tell whether you've got a max or a min, because if you've got a critical point and the graph is concave down at that critical point, the picture tells me, oh, that must be a maximum. Whereas if you've got a critical point and the graph is concave up, then you know you've got to have a minimum. And so again, it sort of depends on the type of information they're giving you. You might be able to use the first derivative test, that number line. You might have to use the second derivative test. One of AP's favorite types of problems is where they give you a graph of a function and then they create a new one, new function based on that using an integral. And as soon as you see this, whoops, this should be an x, where the variable is one of the bounds of integration, you're going to want to use that fundamental theorem of calculus that we talked about in the last video. And so the first thing you're going to write down on your paper is, oh, I know what g prime is. It is f of x. And so this graph that I've got is f, but it's also g prime. And of course, that means if I want to know the second derivative of g, that's just the first derivative of f. And so they will now probably ask you some questions about the function g. And so they could say, for example, where are the maxes and mins of g? And so the easy mistake is people look and they say, oh, here's a maximum, I'm just going to write that down. But of course, this is not the graph of g, this is the graph of f, which is g prime. And we know from our number line example that we're going to have maxes and mins when the derivative changes sign. Well, where does the derivative change sign in this case? It's at 1, 2, 3, 4, 5. And so I know that x equals 5 is going to be a relative max. And why do I know that? Well, because g prime changes from positive to negative there. And you have to be super careful in these problems, right? What function are you talking about, right? I'm talking about the derivative of g, right? And it's changing from positive to negative. So you really want to avoid saying it changes from positive to negative or anything like that. Then if they ask about points of inflection are where the second derivative changes sign. And the second derivative of g is the first derivative of f. And so where does this second derivative change sign? Well, that's when the graph changes direction. When the graph of f changes direction. So f is increasing here and then decreasing. And you should be a little nervous because that looks like it might be a sharp corner. My drawing's a little hard to tell. Turns out it doesn't matter. If the second derivative is undefined or zero, you have a potential point of inflection. And this is a point of inflection at x equals 2 because, and so that's for g again, point of inflection for g of x. because, and here's where you want to be clear on your explanation, because G double prime, which I already made note, is the same thing as F prime, changes sign there, right? It's not enough to say the second derivative is 0 or undefined. You must call out that it changes sign there, right? Changes from positive to negative. And so G would be concave up on this first interval from 0 to 2 because G double prime is positive. And then this whole second part, G double prime is negative. And so as G double prime is negative, it will be concave down. X equals 2 changes from concave up to concave down. And we've got a point of inflection. So these problems, I think I put one in the practice. AP likes them. It gets at lots of big ideas. And so make sure you're thinking about them carefully and asking questions if you have them.